Welcome to the Stutzman channel. My name is Terry and I have a question for you. You are working in an industrial environment. You have 20 control cabinets inside this here plant, and in each cabinet you're going to have, say, 25 contactors, overload relays, and relays themselves. And while the equipment is running, because you cannot shut down processing, you need to check the contacts on all of these here relays. So we're talking about, say, 50 relays, contactors in each cabinet, 20 cabinets, so you got 1,000 contactors to check. Maybe you're going to have 3 contacts per each relay contactor, so what is that? That's 3,000 contacts you got to check. How you going to do it? You're going to check the resistance? You're going to power things down? No, you can't do that. So in this video, we're going to show how to check contacts on equipment that is running, which is actually the best way to check the condition of contacts, and that could be contactors, relays, overloads, pressure switches, temperature switches, contacts on thermostats, anything that has a contact. So this is what we're going to do, and to demonstrate that, we're going to be using this heat pump. So we're going to be checking the contacts here on this here contactor here. In this case here, we only have one contact, because usually in AC units and heat pumps, we usually only have one contact for a 2-pole contactor, where we have a bus bar for the other side. But we still need to check that other side because we have a bus bar. And even though it's a jumper, we still want to make sure that there's no resistance on that side also. So let's get started and we'll see how it's done. Now, I want to make sure that I got my safety glasses on and I have my high voltage gloves. If you want to know more about these high voltage gloves, I did a video 2 videos back where I was using these, and I went into some detail about it and showing the part numbers. So I'll put a link in the description of this video if you want to know more about this. Alright, so let's go ahead and get it started. Now here's our contactor. Now this is a 2-pole contactor. Each side has 120 volts. Between the 2 legs, L1, L2, I should have about 240 volts. Now my line power is coming in on the bottom. Now typically in an industrial environment, you're not going to see the line power coming down on the bottom. In fact, in industrial commercial applications with contactors, you're always going to see the line power coming in on the top side. Even on the contactors, you'll see the L1, L2, L3, if you're talking about 3-phase circuits, they will have all of this here numbering up on the top of the contactor. And then T1, T2, T3, that'll be on the bottom of the contactor, which is a load side. So, in AC units, heat pumps, typically you will see that they will put the wires that are coming in on the bottom side. And usually I do this because of the small confined space that we're talking about here. So when the line power comes in, so that they don't have to wrap the wires around, creating all of this extra space in a small enclosure going up to the top, we just run it on the bottom. Okay, now just so you can see the voltage coming into this here between L1 and L2, see I'm coming on the bottom, and you can see that the voltage is 242 volts. Now, if I go to the load side, which is up here on the top, you can see that I've got 241.8, it looks like, 0.9, 242, okay. Now, here's how we check our contacts. You're inside that industrial environment. You got all of these here contacts that you need to do, and the equipment's running. All you have to do, and you got to make sure, of course, that the contactor is pulled in. You have current going through the contacts, and we know we got current because we hear the compressor running, the condenser fan is running. So we're not going to be checking the amps because we already know it's there. So all we have to do, if you look on this side over here, you can see I have this bus bar that I was telling you about earlier. So if I go right across that, and I make sure I got a good connection here. Okay, you can see I got 0.01 volt. That's 10 millivolts. Okay, 10 millivolts. Now, let's go over to the contact side, which is over on the right. So if I come over here, go to there, go directly right across that contact, And you can see that I've got 0.02. So that's 20 millivolts. Now, I've done a lot of checking with a lot of contacts and relays, and in an industrial environment, anything we look at is 50 millivolts or less, we're good. The closer this voltage is to 0 volts, the better that contact is, and that we're done. We don't have to power it down, we don't have to take wires off, we don't have to make sure we push it in or make sure the contact is pushed in, and then we make a resistance check. Because we're putting a very small amount of voltage across the contact with an ohm meter. We have actual current, about 6.5 amps going through this here contact and also through that there bus bar, and we are looking at all these connections. So we know that contactor is good, so we don't have to worry about it. Done. And the way I look at it is, if you got a unit that's running, check everything that you can while it's running. Because when you have to power this down, and then you get in there and unplug in wires and check the resistance, then you gotta wait 5 minutes before you can power this thing before it start back up if you want to do anything that it does need to be running. So do what you can while it's running, and then if it's off, do what you can when it's off. So that is it. So we're done. So we know this contactor is in good shape. Hope you enjoyed the video. We'll see you next time, and we'll have some other interesting stuff that we can talk about. Have a good one.